This video is going to continue with the 7D notes on page 97, and we're going to take up with example 1B. All right, so we'll need to search and find the like terms. So here my variable is v to the second, so v times v. Here it's v times w, so those are not the same. Here's w to the second, so w times w. It's still even different. And then here I have a VW. So these two terms have the same variable combination. So I can combine them by adding their coefficients. So they're going to add up to be a negative 2, and a negative 5 is a negative 3VW. So then I'd have the 3V to the second and minus or plus 4W to the second. All right, so now the other part of this is we need to write it in descending powers of one variable. Well, we have here both V's and W's. So here's what I happen to have written down, but you see it's V to the second. This next term is V to the 1 power, and then there's no V's. So this is in descending powers for the V variable. So if you turned it around and put 4W squared minus 3VW plus 3V squared, it would have been okay as well, because it would have been in descending orders of the W variable. All right, so example C, down here, we have a to the second B, and we have a b to the second. Now these kind of look the same, but they're not. This is a times B, and this one is a times B. So these are not the same products, and this is going to be b to the third power, so b times b times b. If we look at it, and think in terms of a's, we can't combine anything, so no combinations. And now putting in a descending order, we see have a to the second, a to the first, no a's. So this is in descending order of a's, so we can accept that as our answer. And then D, here we have M times N times N, so not the same. Here's M times M and N times N, not the same. But here is another M times N times N. So we are going to combine the first and the last terms because they have the same variable combination. So I'm going to add their coefficients. Positive 6 and a negative 4 adds to be 2. And remember that when we're doing the variables, Power Man tells us when we're adding, we do nothing with the exponents. So the exponents stay exactly the same way. So 2m into the second. It's kind of like adding apples to apples or subtracting apples from apples. We've got something that we're going to subtract from each other. All right, and then we've got the plus 3n squared and minus m squared n squared. So now we need to put it in some kind of a descending order. Let's say we're going to do the m's. So if we were going to do m's, we're looking for an m to the second, which is this last term. So negative m to the second, n to the second. And we're looking for a single one, which is right here. So plus 2m n to the second, and then plus 3n squared, which has no m's. So my answer would be here. Notice that the n squareds are all the same, so you couldn't put that in descending order for the n's. So for example 2 on the next page, we're going to add this polynomial plus the second polynomial. So we're adding polynomials. And when we do, we're going to combine like terms. So here we see we have an x squared and an x squared, and there's no other ones in there. So I'm going to add them by adding their coefficients. So I have 5 plus 3 is 8x squared. Then we'll combine our xy's, because you can see these are already in descending order. So I have a minus 3xy and a negative 2xy. So I'm going to add the negative 3 and the negative 2 and get negative 5. So add their coefficients and then keep the same variable combination. And then finally we'll add our 2y squared and our plus 1 understood 1y squared, and we're going to end up with 3y squared. So we'll finish up these notes in the next and last video.